Today, I would like to show you how to derive the quadratic formula. So the quadratic formula tells us the x-axis intercept values for a parabolic function. So the quadratic formula is this expression here. X is equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. For a function f of x is in the form ax squared plus bx plus c, where a does not equal 0. So to derive the quadratic formula, it's actually a pretty simple two-step process, where the first step is completing the square. So the reason that we complete the square is so that we end up with an expression which has one x term. And that's important for step 2, which is simply to isolate the x term. Hence, we need to do step 1 first, which is to get a single x term so that it's easy enough to isolate. Once we've completed step 2, this is actually the solution or the result, which is the quadratic formula. So let's get started with step 1, which is to complete the square. So to complete the square is to take a quadratic expression in this form, which we've referred to above, and to convert it into another form, which is like alpha is equal to a x minus h squared plus k. And this here is actually our turning point form. And the reason it's called the turning point form is because if you have like a quadratic equation, which is y is equal to this, then you know that the turning point will be at x is equal to h and y is equal to k. So that would be the coordinates of your turning point. So the first step in completing the square would be to factor out a from this expression. So what we do is we say that this is equal to a bracket x squared plus b over a x plus c over a. So we've just taken the a term out as a factor. So the next step in completing the square is taking the coefficient of x, which is b divided by a. First we halve that, then we square that, then we add that term, and then we subtract that term. It seems a little bit obscure, but you'll see why in a short while. So it's a x squared plus b over ax plus the coefficient of x, which is b on a. We halve that, and then we square it, and then we subtract that same term. So b over a over 2 all squared, and we still have this plus c over a term. So we've just added and then subtracted the same term. So we haven't done anything mathematically incorrect. But the reason we've done that is so we end up with an expression over here, which we can factorize into a perfect square. So that's the next thing that we'll do. So we've got a is equal to, and then we'll factorize these first three terms. And that factorizes nicely into x plus b over 2a all squared. And then we've still got these two terms at the front, at the back, sorry, which we haven't done anything to. So we'll just leave them as is, except I'll simplify this term here so it's nicer to look at. So subtract b squared divided by 4a squared, and we still have this plus c divided by a. Now let's just do a sanity check with this over here to make sure that we've correctly factorized that. So that is x plus b on 2a multiplied by x plus b on 2a, which is just x squared plus b on 2a x plus b on 2a x plus b squared on 4a squared. And if we were to collect the like terms, what we'll end up with is just these three terms here. So things have gone as expected. So the next thing that I'll do is I'll put these two terms over a common denominator, just so it's a bit neater. So we have a bracket x plus b on 2a all squared. subtract, so we'll just cross multiply here. So b squared a plus 4a squared c divided by 4a cubed, and that is equal to a x plus b on 2a squared. Subtract, and let's divide the top and bottom both by a. So we've got b squared minus 4ac divided by 4a squared. And the last step that we'll do is we'll distribute the a by multiplying it into both terms. So that is equal to a x plus b on 2a squared. Subtract, so we're just multiplying the a through this. So we'll just take a power of a away from the denominator. So b squared minus 4ac divided by 4a. So what we have here is an expression which is in the form alpha x minus h plus k. All we have here is that alpha is equal to a, h is equal to negative b on 2a, and k is equal to negative b squared minus 4ac divided by 4a. And this here is our turning point form, which is exactly what we wanted to get out of completing the square. So step 1 is complete. So now let's begin step 2, which is to isolate the x term to reach our quadratic formula. But how do we isolate the x term if this is just an expression and it's not actually an equation, right? An equation has an equal sign somewhere. So let's just remember that this is actually just a rearrangement, right, of our original quadratic equation, which is ax squared plus bx plus c, right? So what we do is we remember that the quadratic equation tells us the x-intercepts. So we can find the x-intercepts by setting the expression to equal to 0. So that's the starting point for us. So let's write this out. We've got a x plus b onto a squared, subtract b squared minus 4ac divided by 4a is equal to 0. So the first step would probably be to divide both sides of the equation by a, just so we can get closer to isolating our x, which is hidden away within this bracket. So dividing both sides by a gives us x plus b on 2a squared, subtract b squared minus 4ac divided by 4a squared, and that's still equal to 0. And let's just write that out, divide by a. The next step would be to add b squared minus 4ac divided by 4a squared to both sides. So x plus b on 2a squared is equal to b squared minus 4ac divided by 4a squared. Let's write that out. So we'll add b squared minus 4ac and 4a squared to both sides. The next step would be to take the square root of both sides. So we end up with x plus b on 2a is equal to plus minus the square root of b squared minus 4ac divided by the square root of 4a squared, which is just equal to plus minus the square root of b squared minus 4ac divided by 2a. And the last step is trivial, right? But let me just write this out. We take the square root of both sides. The next step is just to subtract b on 2a from both sides. So x is equal to plus minus the square root b squared minus 4ac divided by 2a, subtract b on 2a, right? And the step that we've done here is subtract b on 2a. And now it's just a matter of moving this term to the left-hand side of the equation. So we see something which we're more used to. X is equal to b, negative b on 2a. And let's combine the terms because they have a common denominator. Right? So what we actually have is negative b plus minus the square root of b squared minus 4ac, all divided by 2a, and this over here, oh no, and this over here is our quadratic equation, and we've managed to derive that from scratch for ourselves.